Alright, so today we're going to get into moles to grams and grams to moles, or mass conversions. So we've done moles to particles, and now we need to go, if I know a certain amount of moles, how many grams is that? So we know that from our talk about molar mass, we know that the molar mass is the mass of 1 mole of a substance. So if I know that the molar mass is the mass of 1 mole of a substance, then I can use that as a conversion between grams and moles. So let's say I have, for instance, 3.5 moles of carbon dioxide. And I want to know how many grams is that? How many grams of carbon dioxide is that? Well, I must first figure out how many grams are in 1 mole. Well, that's where I go to my periodic table and I find the molar mass first. Okay, so I know I have C and O. Carbon on the periodic table is 12.01. Oxygen is 16. I have 2 oxygens, so I have to multiply that by 2. So that gives me 32. And then I add these 2 numbers together, 12.01 plus 32, that's 44.01 grams per mole. Okay. So now I'm going to set up a dimensional analysis problem where I start with my moles, start with my given. Okay. And just like with particles, I'm going to use the mole, but instead of using Avogadro's number here, I'm going to use this molar mass, grams of CO2, because I know that in 1 mole of CO2 there are 44.01 grams of CO2. Okay, and then now I'm going to multiply the top and then divide by the bottom. So I'm going to do 3.5 times 44.01, and I get 154. So that would be 154 grams of CO2. Okay. So let's do another one. If I have, let's say I have 2.75 moles of sodium chloride. Again, how many grams is this? Well, I need to figure out my molar mass. So always your first step when you're doing these is to figure out the molar mass. So I know sodium is 23, chlorine is 35.45, and we just have 1 of each, so I don't need to multiply. So that's 58.45 grams per mole. I'm going to set up my problem over here. 2.75 moles NaCl, 1 mole NaCl on bottom, 58.45 grams NaCl on top. Then I do my math. 2.75 times 58.45 gets me 161. That's 7 would round to 0 up, so 161 grams NaCl. Okay, now what about going the other way? So if I have grams, I'm trying to get to moles. So let's say I have 123 grams of magnesium nitrate. And how many moles is this? So we're still going to do a very similar thing. It's just going to kind of be backwards. So up here we were multiplying by the molar mass. down here, if we're going grams to moles, we're going to divide by the molar mass. So I still need to find the molar mass for magnesium nitrate. MgNO. So magnesium is 24.31, nitrogen is 14.01, oxygen is 16. This 2 goes to everything in the parentheses, so I have 2 nitrogens, I have 6 oxygens, so that would be 96. This would be 28.02, and 24.31. Then I'm going to add those up, so 96 plus 28.02 plus 24.31 gives me 148.33 grams per mole. All right, and then I'm going to set up my problem. So I have I have 123 grams MgNO32. 1 mole MgNO32. In this case, the mole goes on top, and the grams are going to go on bottom. So the molar mass would go on bottom, because we're doing it, again, this is grams, so it has to match what is on the bottom so that we can cancel it out. So now I'm going to do 123 times 1 and then divided by 148.33. So 123 times 1 is itself, so divided by 148.33 gives me 0.829. So 0.829 moles. Okay. So that is how you do grams to moles conversions. I hope this helps. Let me know if you have any questions.